Hmm. Okay, this is the video for August 1st, and previously in the last lecture we introduced the container for our simulation domain. So now we wanted to introduce some capabilities. So as the first trial, we wanted to introduce the deposition here. Although that is written as deposition, so this is just anisotropic deposition from G direction. So it's nothing special. So in my opinion, isotropic deposition would be much more complicated, but right now we will just consider this directional isotropic or anisotropic one. So it's like this. We create a simulation domain whose scale is given by 10 by 10 by 3. So you can expect that relatively this is wide and short. And in this case, first we save it with the name like bedrock.cgns. After that, we once call this depot of argument 1. It means that we will just, what can I say, just make one level deposition. After that, save it as depot 1. And once again, one more layer is deposited and it is called depot 2. And once again, and it is called depo3.cgns. So what we can expect is starting from this original one. So after 1, 2, 3 of these depo files, then we are observing the increasing level of our blocks. Okay, so then how can we implement this depot um, code? So let's go to the craft. So here you can see that this is corresponding to the deposition. So mm, we will just repeat this job with a thickness. In this case, it is just 1, so we just perform one time deposition, but by changing it to 2 or 3, then we can just make one step deposition, after that repeat it once again and again. And this is the net simulation domain for our XY plane, and for each point in this xy plane, just to make a one-time deposition. So when you go to the uh, mesh file, then this is corresponding to the implementation. For given x coordinate and y coordinate, we just start from top, and if it is empty and its lower one, the iz minus 1 is not empty, then we say that okay, this is the place to add additional elements. So add the element here, and we just escape from this depot. So this is quite simple, and when we just do it, then we will eventually get some increasing level of cubes. So, well, let's do it together. Okay, now we have executable, so let's just run it. Yes. So now when we just list all CGNS files, then now we can find there are 4 of them. The initial structure containing only container and one level and two levels and three levels are deposited in these files. So why don't you just have a look at them? Yes, so you can just compare bedrock.cgns and depo1.cgns. So in order to make a comparison, so I prepare to render view, and in the left one I just show the bedrock.cgns. So you can see that the inner part is 10 by 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the 10 by 10 XY plane, and you can see that the net space has the height of 3. Okay, so this is the original one, and what we can expect for depo1.cgns is this level is filled with newly added layer. So now let's go to that one. So now we have quite a similar one, but why don't you just share the camera? Okay, so by clicking this, now they share the camera, but only share the camera, so the presentation that is not shared. So now let's have a look at them. So they have the same size, and now you can see that this is 1, 2, 3. This is the original scale, and now you can see that there is only 1, 2. Why we don't have the third one? Because that is now filled with, yes, is the deposited layer. So, for example, if we just open another one, depo2.cgns, so, and once again, thank you. Oh, okay. So now is more clear that this level is additionally increased. So this is the original one, and deposited only one layer, and this is corresponding to the result of depositing two layers. So yes, I think that that's it for this video. So right now we don't care about the pattern, so entire system is just filled with these layers, because when we come back to our implementation, then this deposition doesn't care about a window. So deposition window, there's nothing like that. It is just to uniformly deposit all over our XY plane. Of course, we can improve it later, but this is for our next videos. Thank you.